Java cleans up after you. You can create all the objects you want, and when you get finished with them, Java grabs them and uses their memory when you make new objects. You don't have to do anything, it just happens all by itself. This has worked out so well that newer languages are adopting the technique, and older languages are having it retrofit into their new versions. The first trick of garbage collection is the determination by Java that something is ready to be recycled. The basic rule is simple. Anything that you created with a new statement will be garbage collected when your program forgets about it. Every time you stick the address of an object in a reference, Java makes a note of it. When you erase that address, Java makes a note of that too, and places the address in the list of those that are to be reclaimed. Look at this line of code. This creates an object, but it doesn't store the address anywhere. Java makes note of that fact and recycles the memory, uses it to create the new objects. Now look at this. You have stored the address of the object in a reference, and you may use it again, so Java leaves it alone. As long as the address of the object is in that reference, no garbage collection takes place. However, if you erase that address, like this, the object can no longer be found by your program, so it's listed for recycling. It doesn't matter how you erase the address. You could do it by creating a new object and overwriting the address of the old one. The old address is gone from your program, so Java takes charge of the object. Another way to do it is have the reference disappear. That happens when you create an object inside a method. When you call this method, it creates a rectangle object and stores its address in a local reference. It uses the values for the rectangle object to calculate a return value. When the method returns, the rectangle still exists, but the reference to the rectangle does not exist. Your program doesn't know the address of the rectangle object, so Java schedules it for garbage collection. Java always knows if you have any way to get to an object. One interesting situation is, say, when object A holds a reference to object B, B holds a reference to C, C to D, and so on down the line. As long as you have a reference to A, the entire chain of objects is available to you, so Java will not reclaim anything. However, if you drop the address of A, the whole chain will be recycled unless there are other references to some of the other objects in the list. Garbage collection does not take place immediately. The garbage collection process takes time, so it runs as a low-level background process. Different environments and different Java virtual machines will do garbage collections at different times. Your program cannot depend on garbage collection being done at any particular time and in any particular order. If you have an object that is holding on to some resource, then you should release that resource yourself before you drop the object. This sort of situation can arise if you have a file open inside an object. You should always close that file first. It is possible that the object won't be recycled before the program finishes running and exits. Now that will close the file, but holding it this way could cause it to be closed without its buffers being flushed properly, and some data could be lost. Besides, your system may not let you hold all those files open all at once. If you are creating objects and your program needs to recycle old objects into new ones just to make room, it will do that automatically. When you invoke the new keyword, Java will get the memory for you if it has to invoke the garbage collector to do it. But if you want, you can invoke the garbage collector from your program. These two lines of code do it. The runtime object that you retrieve this way is a representation of the runtime system for your program. It has the method gc, that is the garbage collector. When this method returns, the free memory has been reclaimed. Just before the garbage collection reclaims the memory of an object, it calls the finalize method. This is one of the methods defined in the object class, so every object has a finalize method. If there is something special that you need to do before an object is reclaimed, you can do it in this method. You can even call the method yourself before you drop the address of the object. If you decide to write your own finalize method, you'll need to include a call to the finalize method of the superclass, or it won't get called. Here's an example. The method is declared as protected, and it's declared as possibly throwing an exception. Both of these items are explained later. A call is made to the finalize superclass. In this example, the file named log file is closed if it has been left open, but don't count on this happening. If your program ends, the Java virtual machine may just shut down without ever calling finalize.